Hi there, seventh graders. So this is Mrs. Oliver. If you get a chance, I highly suggest joining your live Google Meet for this instead of just watching. It'll probably make more sense if you're doing it with the class. Okay, so today we are working at I will determine if a relationship is proportional or non-proportional. Okay, so we're going to have to compute finding those unit rates, the same thing that we've been working on since last week. Okay, so we have 110 miles in 2 hours. That means you're driving pretty much at 55 miles per hour. Right now, sometimes we have to look at tables to find our unit rates. And that is because eventually we are going to be matching and knowing if an equation is proportional that is graphed from its table. Okay, all built in together. So we did unit rates day 2, complex fractions with unit rates. Now we're looking at proportional and non-proportional relationships. So you have one page of notes, and it's more of a hands-on activity today. Okay, so I started filling out this one just to save a little bit of time. Okay, so there are carpet tiles in the classroom, and each tile is 2 feet long. But if you notice, we want to know what it is in inches. So I went ahead and put in what it is for inches. If we had 2 tiles, what would that measure? It would measure 48 inches. 4 tiles, it's 96 inches. 6 is 144. 8, 192 inches. 10 tiles makes 240. Okay. So then what we want to do is we're going to compare our length of each tile to how many tiles it was. So I'm really taking my 0 over 0. Well, that of course equals 0. Okay, if you have no tiles, you have no length. Okay, but if I have 48 inches and 2 tiles, because that was the length, and this is how many tiles there was, that makes our 24. And if I had 96 inches for 4 tiles, if you divide that, you get 24. 144 inches for 6 tiles, you get 24. 192 inches for 8 tiles, you get 24. 240 out of 10 tiles, you get 24. So what is something that we notice about the table or ratios? Okay, because our ratio is taking the two numbers and then computing it to find its unit rate. So one thing I noticed, what do they all reduce to? Okay. They all reduce to 24. We could say also look at how do they increase? If my tiles increase up by what? So tiles or our x value, tiles increase by 2s, and our inches increase by 24. By 24? Not 24. 48. Increase by 48. That's what they're increasing by. Right, if I took 96 minus 48, I get 48. 144 minus 96, I'm going to get 48. All right. Well, now if we have some cups, like the plastic cups, and you measure them, stacking them, and then centimeters, how many centimeters tall is it? That is an activity that they'll do with the class, so make sure you tune in to see what you would get with that. And while the students one, I can kind of help you out with that one. I don't have any plastic cups here at home to measure. All my cups are glass. They're all the same length. Okay, so say I have students lining up and they're laying down on the floor and we want to measure their height. I have no students. We know we have no height. Okay, so say one of the students, we measure their height and they're 62 inches. Okay, Then we have a second student that is measuring their height along with the first student. So the first student is the 62 inches. Maybe the other student is 65 inches. So together we have 127. Okay. Then we have another student that's kind of more taller. Say they are 68 inches. So then we have a total of 195. Okay, so we're going to want to compare our length of inches to how many students there was. Okay, so I had 0 students, 1, 2, and 3, and then our inches. If you notice, every time we're at 0, I got 0 out of 0. Okay, so 62 over this, which gives me 62. 127, but what is 127 divided by 2? That's actually 63 and a half. And then 195 being divided by 3 is 65. Okay, so what's something that we notice about this? Okay, what do you notice about the table or the ratios? Well, do they increase all at the same rate? So they do not have the same unit rates. Okay, so they didn't reduce to a common number. Do we increase going from one height to the other height at the same rate? No. So we could say inches do not increase the same. So our students does, it increases by ones. Okay, so if you just even look at just those two and how they're different. So our student height one, and then this one up here, they're kind of built on what we're going to do for our notes. Okay, so a proportional relationship is a relationship where the ratios are, I have the right thing selected, equal. They all come down to be the same. All right, a non-proportional relationship in which the ratios are not equal. Okay, so we're going to make another table. Okay, so Andrew earns $12 an hour mowing lawns. Is the amount of money proportional to the number of hours? Okay, so let's talk about how many hours he's working. Okay, if he doesn't work at all, say Saturday morning he works nothing, is he going to make any money if he doesn't go mow lawns? No, so that stays at 0. Okay, let's say he works 1 hour. So how much is he going to get made? That $12. Say he mows for 2 hours. Well, he's going to make 24. 3 hours, add another 12, you're going to get 36. 4 hours, and he's going to make $48. Okay. Now, when we compare our ratios, if this is an X value and that's a Y value, and we will go into more detail. You always want to compare your Y over X. So we're going to compare our money to our hours. Okay. You have your independent and dependent, just like you learn in science. It's the same thing with this as well. Okay, so all my Y's is 0, 12, 24, 36, 48. Yep, that's it. We had extras in there for you. So 0 hours, 1 hour, 2 hour, 3 hours, 4 hours. Okay, so this becomes 12, 24 divided by 2, 12, 36 divided by 3, 12, 48 divided by 4, 12. So did all of these equal? Not including the 0, because when you're always going to have 0 divided by 0. It's actually undefined because you can't divide by 0, but that's where we're going to something important about having your 0, 0. And you'll find out about that when we get to our graphing. So would we say this is proportional or non-proportional if we go by if we're the same or not the same? This is proportional. Right, because they all decrease and increase at the same rate. $120 in the bank. Each week she deposits $20. Is her bank account proportional to the number of weeks of deposits? So in her very first week, she had 120. Then she increased by $20 each week, which would seem like it's proportional. But because she already started with 120, it changes what you're actually going to get. Why did I put 170? This should be 170. Okay, so since these do not reduce to being the same, it is non-proportional, even though it is increasing by the same amount, because we did not start with 0, then it ended up being unproportional. All right. All right, so now you have an exit ticket. You are looking at 2 tables. Which situation represents a proportional relationship between hours worked in amount for Matt and June? So either Matt or June has a proportional table. All right, so you need to compare those and then say which person is it and what is the constant rate of pay. Okay, so whoever has where the ratios and come down to being the same, that's the person that is your proportional. And then what do all the ratios reduce to be the same? All right.